All right. We have a complicated looking integral for this one, but I recommend that we don't try to do it all at once. Let's split it up into pieces and write it as integral of 3 dx plus 1 over x dx plus e to the x dx and minus square root of x dx. Place our integral symbols around all of them. Now, integral of 3 dx is pretty doable as is. We don't need to make too many changes to it. But this integral of 1 over x dx, you may have seen previously written as dx over x. So let's write it that way. And then you have integral of e to the x dx. And then this last one that has square root of x, let's write that as x to the 0.5 dx. Now, if you take the integral of a regular old number, all you have to do is put on an x. So the integral of 3 dx is just 3x. That's it. Now, integral of dx over x, you may have seen before, this becomes natural log of x. So you have plus ln of x. The integral of e to the x is just e to the x again. So you get plus e to the x. Now for this final integral. For this one, it's a decimal number, so we add 1 to the power and divide by the new power. So you will now have x to the 1.5 divided by 1.5. And at the very end, we put plus c. Again, the plus c is there to show that this is an indefinite integral. If this was a definite integral, you would have had a starting number and an ending number on the little integral curve. So this entire thing is our answer. Now, it wouldn't have paid off to try to do this whole thing at once. When you have plus signs in the middle of the chunks, most of the time it's going to be easier to do it separately rather than all together. Okay, for this problem, we have integral of 5x times x squared minus 3 raised to the 7th. To do this by u substitution, you might notice that we have x squared minus 3 buried inside of another function. And that's buried inside of something to the 7th. So let's let the inside function become our u. So our integral begins as 5x times x squared minus 3 raised to the 7th dx. But let us replace this x squared minus 3 with u. So now this integral becomes integral of 5x times u to the 7th dx. Now that we know where to place u, let's think about how to replace this dx. But there's a couple of steps we have to follow to get there. So to replace dx, we are going to start by writing u. Now u, as we said a moment ago, was going to be x squared minus 3. What we need to do once we've written that is take the derivative. It's a little ironic that in order to take an integral we have to first take a derivative, but that is how u substitution works. So derivative of u is just du dx. And the derivative of x squared, we bring the 2 around to the front. And then we take x and knock one power off of 2. So x squared becomes x to the first. And the derivative of negative 3 is, of course, 0. So we can just leave that as is. So from here, we can solve for dx. So what we can do here is what I call the swap trick. Now, anyone who's worked with me for a while might have seen this. What we do is we switch this dx with this 2x to the first. Because this dx is on the bottom and this 2x is on the right, it is okay to switch those two positions. So now we'll have du over 2x is equal to dx. And at this point, once we have solved for dx, we can move that back into the integral. Okay, so this dx gets replaced with du over 2x. The reason why we took this derivative and then manipulated what we got was so that we could replace dx with this fraction. So now our integral changes again, and we have 5x times u to the 7th times du over 2x. Now, what we can do is we can simplify again. Okay? Now, everything's kind of in pieces right now. So let's put it all together here. Let's first take the constants, the 5 that's on the top and the 2 that's on the bottom, and move them outside of the integration sign. We will have now 5 on the top, 2 on the bottom. Take it outside of the integral because we don't need them inside the integral. And we'll have x times u to the 7th du over x. But now, since you have x on the top and x on the bottom, they cancel out. And now we'll have 5 over 2 integral of u to the 7th du. So remember, now we can just take the integral. Now to take the integral of u to the 7th, we now add 1 to the power and then divide by the new power. So u to the 7th becomes u to the 8th divided by the new power, which is 8. We'll have 5 halves times u to the 8th over 8. And now the last thing we do is replace our u. So at the very beginning, we said u was x squared minus 3. So our final answer is going to be 5 halves times x squared minus 3 over 8, and we will put on a plus c at the end. And there we have it. That's how we do the integral. So this was a fairly complicated u substitution integral. We begin by deciding that u is the inside. We took the derivative. We solved that derivative for dx so that we could replace the dx in the integral with something in terms of du. We pulled the two constants to the outside, 5 on top, 2 on bottom, both come out. We canceled the x's. to get a much more workable integral, u to the 7th du. So integral of u to the 7th is u to the 8th over 8, still times the 5/2, and then we just replaced u and make sure that we remember to put the 8 up there. All right, for this question we have the integral of x to the 3rd over 4 minus 2x to the 4th. Now here we have a fraction, but we might recognize that the higher power is on the bottom. And more importantly, you might notice that the top is 3rd power and the bottom is 4th power. Now, u substitution works well when you have a fraction, but the powers are 1 power apart. In that case, we would let the u be the one that is higher power. So we'll say that u is equal to 4 minus 2x to the 4th. If we make that replacement in the integral, we'll have x to the 3rd over u dx. That takes care of part of it, but now let's try to get dx, and to do that we have to take the derivative. So if we take the derivative, we'll have du dx. The derivative of 4 is just 0 because it's a constant, so that doesn't change my answer. Now I have to take the derivative of negative 2x to the 4th. I bring the 4 down, and I will also reduce the power by 1. So I will have negative 2 times the 4 that I brought down, and then my x will no longer be 4th power, it'll be 3rd power. Therefore du dx will be negative 2 multiply 4 gives negative 8 x to the 3rd power. Now I want dx as my answer, so I'm going to swap the dx with what's on the right and exchange their positions. So I can say that du over negative 8 x to the 3rd is equal to dx. Now I can replace the dx that's over here in my original integral with this fraction. Du over negative 8x to the 3rd will be placed in this position. And I'll have integral of x to the 3rd over u times du over negative 8 x to the 3rd. Now, let's pull out our constants. So I do have a constant in the bottom, that's negative 8. I have no constant on top, so I can just use 1 if I have no constant on top. Make sure you don't say 0 on top here. We're going to use the invisible 1. Now, I've gone ahead and added it in blue here so we can avoid that confusion. So, the 1 on the top, that was not originally written, but we can add it, and the negative 8 on the bottom can be pulled out, and we'll have negative 1/8 integral of x to the 3rd du over u times x to the 3rd. Now, let's look at what we can cancel. Since we have x to the 3rd on the top and the bottom, that can be canceled out completely. And this will give us negative 1/8 integral of du over u. But if we integrate du over u, we will get natural log of u. So when we integrate, we'll get negative 1/8 natural log of u. Then all we'll need to do is replace the u that we got earlier. So previously, we had said that our u was 4 minus 2x to the fourth. We can place it in the u position. So we'll have negative 1/8 natural log of 4 minus 2x to the fourth plus c. And that will be our integral. So this one looked a little rough at first, but again, just by picking a u that is the higher of the two powers, that caused all of this stuff to cancel out. That got rid of our x to the third, and it allowed us to remove our constants to the outside to where they didn't have to be involved in the integral. Once we're finished, we just got du over u. The integral of that is just natural log of u. Then once we replace the u, we are okay to go. All right, for this problem, we have a square root. Now let's remember that square roots are really just 1/2 exponents. You can also use 0.5 if you like. In fact, I'm going to go with 0.5 for this question. So we can let u be the expression that's buried in the square root. So we'll say that u is equal to x squared minus 4x plus 1. This will change my integral. Now, if I replace the inside of that square root with this u, I'll have x minus 2 times u to the 0.5 power. You can write it as a fraction also, but I'm going to use the decimal because it's a little easier to handle mathematically. But now that we know what u is, remember that we have to include that dx, and we need to replace that dx with something else. Our first step toward that is to take the derivative of u. So if we take this derivative, we can say du dx is equal to the derivative of what's on the right. To get the derivative of x squared, we take the 2 and move to the front. And then knock one power off the x squared, giving us 2x to the first. The derivative of negative 4x is just negative 4. Just remove the x, keep the number. The derivative of 1, since that's a constant, the derivative of that is just 0, and we don't have to write anything for it. Now, once again, we can do the swap trick. So let's swap the dx with everything that's on the right. If we make the exchange, we'll have du over 2x minus 4 is equal to dx. We place this fraction in the position where dx is. So if we make that change, we'll have integral of x minus 2 u to the 0.5 times du over 2x minus 4. Now, ideally, we would like to cancel something out if possible. But before we do that, let's try to factor out some sort of constant. So in the top, I don't see any sort of constant that would factor out. But if you look carefully, you might notice that in the denominator, we have a 2 and a 4 in the same expression. So I would recommend that you factor a 2 out of the denominator. So the integral previously would have been x minus 2 times u to the 0.5 times du over 2x minus 4 But if we go to the denominator and factor a 2 out of both of these, we'll have integral of x minus 2 u to the 0.5 du. We'll pull out the 2 now. And if we pull a 2 out of 2x, we'll just have x. And if we pull a 2 out of the negative 4, we'll have negative 2. Now, you might notice that we can cancel the x minus 2 expression because they're both in parentheses. One's on top, one's on bottom. So this can drop out. Now we have a much more simplistic integral than before. We'll have integral of u to the 0.5 du over 2. Now, we'll take the 2 that's from the bottom and the invisible 1 on top, and we can move our constants outside. So on the top we would have 1, on the bottom we would have 2, so we would have 1/2 on the outside, integral of u to the 0.5 du. So when we perform this integral, we add 1 to the power, and then we divide by the new power. So we'll have 1/2 still on the outside, and then our u to the 0.5, if we add 1, becomes u to the 1.5 over 1.5. And for our final step, we can just replace the u, so we'll have 1 times our u to the 1.5. We said previously our u was x squared minus 4x plus 1. And we divide that by what we have on the bottom. 2 times 1.5 just gives 3. Add on the plus c, and our integral is complete. So we'll have x squared minus 4x plus 1 raised to the 1.5 over 3 plus c. So our integral this time is integral of x times e to the 3x squared minus 5. So this is an example of where we have a function buried inside of e. So what I would do is let this function that's buried inside of e become our u. So we'll let u equal the 3x squared minus 5. And notice we're not going to include the e in that. We're only going to use the inside function for this. As usual, we want to take the derivative of this. We need to keep in mind that we are eventually going to replace that dx. So we have to find what dx is. So we take the derivative of u, du dx. For the derivative of 3x squared, we take the 2 and bring it down. So we'll have 2 times 3, x. We knock the power down by 1, and it becomes x to the first. The derivative of negative 5, since negative 5 is only a constant, it'll be 0. Now, if we just take the 2 times the 3, we can say du dx is equal to 6x. Then we can do a swap to get dx by itself. So I'm going to take the dx that was down here and the 6x that was here and exchange their positions. So we'll have du over 6x is equal to dx. Now let's make the changes to this integral. So we can make these changes to the integral we'll have integral of x times e to the u, because we were replacing that inside function with u, and then times our new dx. We'll take this dx and move it into the position the old dx was, and we'll have du over 6x. Now, let's take our constants and move them out. We have a 6 on the bottom, and we have no numbers on top, so we'll use 1 on the top and 6 on the bottom. So now, when I write my integral, I can put my 1/6 on the outside. And I will now have x times e to the u du over x. Now, I can cancel something on the top that's also on the bottom. That's my x. Let's cross them both out and write down what's left, 1/6 integral of e to the u du. But when you integrate e to the u, you get the same e to the u back. So if I take the integral, I still get 1/6 e to the u. Now all I need to do is replace my u. Well, the u I selected previously was 3x squared minus 5. So I'll get 1/6 e to the 3x squared minus 5 plus c on the end, and then I'm okay to go. That's my integral, and that's all we need to do.